Welcome to the final lesson in our series on polynomials. There's much more we could say about polynomials, but we're running out of time. So this is the fourth lesson in our series, and it's on the remainder theorem and the factor theorem. So first, let's have a look at the remainder theorem. If you take a polynomial and you divide it by x minus a, where a is some number, then the remainder is p of a. Notice how minus a and a are opposites. So if you want to know what the remainder of a polynomial is when you divide by x minus some number, you substitute the opposite of that number into the polynomial. Let's have a look at an example. So if I want to know what the remainder is when I divide 2x cubed plus 4x squared plus x minus 6, I'm going to divide that by x plus 3, then what happens is I take the opposite of the plus 3, which is minus 3, and then I substitute that into the polynomial. So everywhere there's an x, I replace it with minus 3. So I have minus 3 cubed, minus 3 squared, minus 3, and all the other numbers line up. So when I evaluate each of those, I get minus 54, plus 36, minus 3 and minus 6, and that combines for a total of minus 27. So by substituting minus 3 in for x, I get an answer of minus 27. And that means that if I could be bothered to divide that polynomial by x plus 3, the remainder would be minus 27. Now you mightn't think that that's very exciting, but actually when we consider that in the next slide, it actually becomes very exciting. And this is called the factor theorem. So if any polynomial, when you substitute x equals a, where a is some number, then x minus a, the opposite of that number, is a factor of p of x. Let's see what this actually means. So here's an example. I have a polynomial x cubed minus 7x plus 6, and I'm going to divide it by x plus 2. Now, if I want to know what the remainder is before I begin dividing, then I substitute the opposite of plus 2, which is minus 2, into the polynomial. So that's the opposite of plus 2, which is minus 2, and I'm going to substitute that into the polynomial. So everywhere there was an x, I'm going to write a minus 2, sorry. So I have minus 2 cubed, minus 7 times minus 2, and the minus 6 remains. And when you evaluate that, you get 0. Therefore, that means there's no remainder. It's got a remainder of 0. But more importantly, if it's got a remainder of 0, that means it's a factor. It divides in exactly into the polynomial. So, off to the right hand side here we have the division process for that, and you can verify there that there's no remainder. So what that means is that the original polynomial in factorised form is x plus 2 brackets x squared minus 2x minus 3. And then if I apply what we learnt late last year about factorising quadratics, then that further factorises into x plus 1 and x minus 3. So the fully factorised form of the original polynomial, x cubed minus 7x minus 6, is x plus 2, x plus 1, x minus 3. So now the whole thing is factorised. This is good news because it gives us a way of factorising things bigger than quadratics, because you can test some numbers to see when you'll get a 0 remainder. And when you've found one, you can use division to break it down and factorise it. So that's a very important process to know how to do. And I hope you enjoy practicing that in our lesson tomorrow. Thanks for listening.